For our first session, I'm here to welcome Malcolm Lewis and Jason Forney. I'll do Malcolm's introduction first and then Jason's later. Malcolm has been a wonderful teacher and mentor to me, and I really am appreciative of him being here today. He's been active in the design of leading-edge buildings for over 30 years as a consulting engineer, specializing in mechanical, electrical, and energy systems. This started with energy-efficient buildings and solar energy systems in the 1970s, and evolved to include intelligent buildings in the 1980s, and now focuses on sustainable design of green buildings. He specializes in integrating innovative technologies into the mainstream of building practice. And he accomplishes this through his professional activities in design, education, and public policy. Malcolm has been the engineer of record for hundreds of commercial, institutional, and industrial buildings totaling over 20 million square feet. He's the energy engineer of several completed zero-net energy buildings and advises clients on zero-net energy and low-carbon strategies for buildings and communities. His projects have won numerous awards for energy efficiency, sustainability, and design. Malcolm has served on the board of directors of the U.S. Green Building Council from 1997 to 2003 and is currently a member of the USGBC's LEED Steering Committee and is chair of the LEED Technical Committee. Malcolm's a Thayer School alumnus, so he always welcomes the opportunity to come back and see us here in Hanover, and he's always extremely generous with his time and with students in particular. He'll talk about the theory and practice in moving from LEED to zero-net energy buildings. Please welcome Malcolm Lewis.
Thank you, Jack. You mentioned intelligent buildings, and that takes on a whole new meaning after seeing Dana's presentation, where it's clear we don't have a clue about how to do anything intelligent compared to what nature does. It's very humbling, and I was certainly very inspired by that presentation. What I want to do is talk a little bit about the context of LEED as a transformational mechanism, because the topic was sort of lead towards net zero and beyond. And I just want to lay a little framework and how LEED relates to codes and to more advanced things in terms of beyond LEED, and then go into some zero net energy building discussions. I think for me, having been involved with LEED from the inception, it's been really gratifying to see the way that LEED has impacted the market interest in high performance buildings. And throughout my talk, I'm going to be on the slides abbreviating performance with PX just because it's such a long word. But I think it's been interesting that LEED has really made a difference in terms of developing the market interest in environmental performance, in motivating manufacturers to develop new products for buildings that are more energy efficient, for even the idea of connecting buildings with environment in a positive way as opposed to something where you're just doing an EIR and trying to prove, what sort of level of damage you're doing to the environment. And I think also it set the stage for what it intended to do, which is transformational change. Traditionally, the building industry has been very resistant to change, and every little change has been very incremental. And the idea of making big leaps in codes and market acceptable approaches to design and buildings and so forth is just something that when I was doing my PhD thesis here and was looking at those kinds of things in relation to manufactured construction and modular housing and so forth, it was seen as one of the most change-resistant industries in our economy. And yet today, I think there's more change going on in the building industry than many other industries around. And I think that LEED can claim part of the credit for that, although certainly it's probably just that it was the right thing in the right place at the right time. As LEED evolves, it has new priorities, GHG reduction, focusing more on going towards zero net energy, the point about water and how critical that is, linkages between buildings and their environments, transportation networks, the idea of place-based environmental factors. I mean, one of the challenges of LEED is that there's a single national system, rating system, wherever you are, whatever kind of building it is, pretty much, with a few exceptions. And that's clearly inappropriate for something that should be as responsive to local conditions, local culture, climate, and so forth as buildings are. And so we're moving to evolve it towards that. And so all of these new focuses are driving where LEED is going. And I should say that these initial comments that I'm making are made sort of not officially for the USGBC, but in my capacity as the chair of the LEED Technical Committee, which is responsible for driving the development of the next versions of LEED. We just issued LEED 2009 last year. We're hard at work on developing the next version of LEED, which is LEED 2012. There's a 3-year development cycle, which drives a lot of people crazy because it's like, hey, we just figured that one out and already there's a new one. But as you'll see in a moment, I think that kind of constant change is really critical if we're going to get where we need to get, given 350, given 2030. We can't sit still. We have to constantly be raising the bar. And part of the context for those comments is that when we started LEED, we just sort of put something out there. We didn't have anything that we really knew that this is a good starting point, and it took quite a few years, several years, for people to sort of get even the fact that there's these 5 different areas: energy, water, site, materials, and indoor environmental quality. And we certainly had no idea whether it would succeed, how it would change the conversation, and so forth. But I think what we've seen is that it has radically impacted the conversation. It was intended to be something that affected only the top 25% of buildings, but almost every building project talks about some of the issues associated with LEED as it goes forward. So anyway, now there's a plan towards higher performance and to evolve it. And that starts from the premise that you've got this sort of, most buildings are starting out as a negative impact. And we would say that even a platinum building is still a negative impact on the environment. But the goal is to start evolving LEED through these cycles to get to the point where ideally in the next 6 or 8 years we would have a building that had a positive impact on the environment regardless of your level of certification. But the question is, how fast can we do that? Is the market ready for it? Are we ready technically, and so forth? And there's this constant stress between market acceptance and the desire to push the market. I mean, market pushes back and says we can't afford it, the market isn't ready, and so forth. So we're constantly testing for that. We also have a lot of work to do to develop technical metrics. I mean, most of the credits for LEED started out prescriptive and relative metric, okay? I mean, it's like X% better than this or whatever. What we're trying to do is move towards more performance-based and absolute metrics where if you're going to get to net zero, that's an absolute amount of energy production or usage, and we need that for water, for materials, and so forth. So that's the goal. But of course, the question is, how do you get there? What are the transitions, both technically and in terms of market acceptance? And part of our goal is to outline a path that will get us towards this idea of regenerative buildings, living buildings, sometime along the lines of 2030. And so what we've done is develop a 3-year by 3-year cycle towards regenerative. I'm not going to talk about what regenerative means. I think there's a lot of debate about that, but we know it's better than what we have today. And so we've developed a roadmap. I don't expect you to be able to read this, but one thing that's interesting is that what we're saying is that by 2018, if we can work it out, we want to have a platinum building be zero net energy, zero net water, zero net waste. The challenge, of course, is we don't know how to do that for many building types and in many climates. but we have to start setting the goal. So we also don't know if we can afford it, but we, again, want to start setting the goal. There's a huge lack of industry capacity to do this, designing it, operating buildings. The technologies don't exist, but we're heading out towards the next frontier. There are lots of interplays between LEED and codes. California has codes stating that, policy in place saying by 2020, any new residential building shall be zero net energy. By 2030, any commercial building will be zero net energy. Standard 189, which ASHRAE just published, really raises the bar for energy, metering, some other things. There's lots of work going on in GHG reduction strategies and so forth. So there's a lot of stuff pushing LEED. You can see that codes which have traditionally been behind LEED are starting to push LEED to go faster. And that brings us to this sort of hierarchy of project performance, from code compliance to LEED to advanced buildings and R&D, new kinds of prototypes and so forth. Of course, the thing that's most interesting is most buildings, existing buildings in particular, are way down here. They're not even close to any of this area. But what we're primarily going to be talking about here today is what's going on at the top end, where we're going beyond LEED for the moment and prototyping what in the next few years we hope to build into LEED, which is the whole idea of zero net energy. So how do you define that? Well, there are lots of ways of defining it. Generally, what I'm saying is a zero net building is a building that has no adverse energy impact, or could be water usage, on the environment. But you have to get into a lot of details about what energy is included. Can you have an interface with the utilities? What are the boundaries around that you're defining it around, and so forth? So it gets pretty complicated. But in general, what we're saying is a zero net building produces more energy on site than it consumes on an annual basis. And that's excluding transportation energy to and from the building and excluding the embodied energy. Ideally, we would include those things, but we're not there yet. There are some interesting publications by the National Renewable Energy Lab, DOE, looking at a bunch of different definitions of zero net that I'm not going to go into right now, but can refer you to. One of the things that document that I just showed you does is define a series of sort of sequences that you go through, starting with energy efficiency and then doing on-site renewable supply of energy within the building footprint, and then outside the building footprint, on a parking structure or adjacent parking lot. Off-site supply, like a wind farm that's down the street or off-site somewhere. Importing supplies of renewable fuels, and of course purchasing renewable energy credits. All of these are ways of moving towards a zero energy building. And in any event, what you want to do to achieve a ZEB is to start with this sort of sequence of things where you're setting goals and then designing the envelope, the systems, and so forth to use the least amount of energy or produce positive net energy, and then teach people how to operate the building in a way that maintains that zero net goal. And the idea is to help people be very clear about what their goal is for setting their energy efficiency goal. Do they just say, I want a green building? Do they say, I want a particular LEED rating? I want to be X% better than standard 90 or whatever the applicable code is. I want to design a particular energy intensity of building, or I want to design a net zero building. Whatever you're doing, you have to start with the kind of sequence shown here, where you first of all reduce the loads in a building, building envelope, lighting loads, ventilation, everything you can do to reduce the amount of energy that's required to maintain the operation of the building. Then you select systems that are as efficient as possible to meet those loads, and then you look for regenerative systems, areas where you can use waste energy for useful purposes in other parts of the building. And finally, then you load on renewable systems, PV, wind, et cetera, that can produce whatever the net shortfall of energy is. The goal then, if you take a conventional building where typically there's 60% of that, what I just described, is in the loads and 40% in the systems, you can easily cut that in half by making a more efficient building, reducing the loads, more efficient systems, and a little bit of regeneration, heat recovery. And you can go all the way to a net positive building if you do even more of those things and then add on renewable on-site production. So a typical project starts with a standard code-compliant case, goes to a efficient case, and then you add on renewables and you can get down to a net zero kind of situation. To do this, obviously, you do a lot of energy modeling to compute what the base case is and then what you can do to drive that down. And you look at a bunch of different strategies parametrically to see what you can do to make your building as efficient as possible. I want to show you some applications of those techniques to 3 projects, all of which are California projects, and I know that in a way they're not terribly applicable to this climate, but I think that some of the lessons learned are still valuable. The first one is a zero net energy housing project in San Diego that uses a lot of photovoltaics, as you can see on the roof. One of the interesting challenges of this was that we needed so much roof area for photovoltaics that there wasn't enough room for solar thermal collectors, which we really needed for water heating as well. And so, but the goal of this was to be as close to zero net electric as possible, and there was a sacrifice as a result. Lesson learned, the roof area is at a real premium for a high-density building that has a lot of people in it like this. And again, this is residential, so it's not that high density energy-wise compared to some other buildings. The goal was not to take it all the way to zero. If we could reduce electric costs on an annual basis by 70% and have the peak demand be less than 1 kW, that was considered a success, as long as it also stayed within the constraint of $5,000 per dwelling unit. I'm just going to jump to one of the things that I think was most interesting. We've been doing measuring for the last 2 years on the usage of this building, and these color codes show individual dwellings within the project, and color is consistently the same unit type. And the range that you see here is the result of very different occupant behavior. Same dwellings, same systems, everything's the same, but radically different amount of electricity used just depending on how people operate their systems, relate to it, and so forth. And the point is that feedback to the occupants is really critical. By the way, over here is the adjacent comparative project that is identical in terms of size and demographics, but clearly very much higher energy use. Here's just some peak demand data showing how much lower the demand is for that project. The next project I want to show you is a Navy project that we actually did in the mid-90s. But the reason it's important here is that it had a zero net energy goal and also a zero net water goal. It has rainwater recapture, gray water treatment. It's a naturally ventilated building and has a large PV array. It also was a renovation, started with a pre-engineered building that we radically, changed the profile of. It got to a net zero reduction the same way as the last one that I showed, and for over 10 years has been a positive producer to the grid, a significant level. It has solar thermal as well. It has both for water heating and for space heating. It has, of course, a lot of lighting and daylighting controls. It's got HVAC heat recovery for additional water heating needs. The daylighting was a radical strategy that every time I've ever been in the building, the lights aren't on at all. It's zero electricity usage. It's designed to accommodate actually a fuel cell and hydrolyzer system to make hydrogen at night, or during the day from PV, and then store it, and then at night produce energy, so you even out the production. The next project that I want to show you is one for Audubon. It's a small project, but again, it's interesting because it's off the grid for electric and for water. And the challenges associated with buildings that are totally off the grid are even greater than just a zero net, where you're using the utility as a battery, if you will. And there were a lot of interesting lessons learned in terms of, this was intended to be a tour de force to prove that you could do it, but in reality what happened was we created a building that was more complex than it should have been. It's got a solar thermal cooling system in addition to photovoltaics off the grid, so battery systems. This is the absorption cooling system. This system failed within a year of operation. Chinese made evacuated tube collectors, and they just split at the ends. And it's taken us years to get back to a system that is now operating again right. So a lot of challenges associated with that kind of project. The water, reclaimed water from the project is used for ponds and so forth on site, and as it turns out, uses a lot more electricity for pumping than we had anticipated. I recognize that these were all easy projects by your standards. They're in a very benign climate, they're small buildings. The challenge, of course, is to try it out in your climate and with increasingly complex projects to see if we can get all the way to zero net. In my view, one of the ways of doing that is to expand it more to a campus environment. It's a lot easier to think about a zero net lab if you've got a dormitory next door that you can put a lot of PV on or something like that. Okay, so you want to think in a larger context. Just some closing principles. Designing with climate is obvious, and yet so many buildings are designed without regard to climate, and we just can't do that. And we clearly need to be using the natural energies of sun for daylighting and you know, heat and so forth. You want to use building scale to work for you, and go to community scale, as I've said, whenever you can. It's really hard to achieve a zero net building that's completely freestanding of any scale. Finally, I think the point that was made by Dana, elegance, I mean, when I use the term elegant, I can't hold a candle to what the elegant systems that she showed us, but we want form to follow function, and that needs to be it's really a challenge for the architects. You guys have to open up and be willing to do different designs that will respond to the climate and to some of these issues. We want to be doing simple systems. That absorption chilling that I showed you for the Audubon building, shame on us. That was too complicated a system for that kind of building. I know why we did it. The owner knows why we did it. Nobody's pointing fingers. But I wouldn't do that again, and I think that's an important lesson learned, that I mean, to the simplicity point that Dana made, we don't need to do this with high pressure, high everything. We need to figure out how to do it more appropriately. And we've done a number of other buildings that are completely naturally ventilated and not cooled at all, but again, it depends on the climate. I've talked about how important user behavior is. The last point I want to make is that data collection of how the buildings really operate is crucial to a successful zero net building. And that leads into operations and maintenance, that getting the building designed and constructed is just the first step of the next 50 years or more of the building. And the occupants of the building, the people operating the building and maintaining the building have to understand and buy into the zero net concepts. With that, well, I guess there's one more. We've talked about it. I always think I'm at the end. You need an integrated design and delivery process. You need to clearly articulate the goals at each step. The designers need to understand and care about and make priority how the building is going to be operated. We have to learn how to predict the absolute energy usage of buildings instead of just so much better than code. And we have to build in the idea of monitoring and verification and feedback and learning lessons. Now I'm done. So I think we have a few minutes for discussion. If there are any questions, I'd be happy to take them. Yes, in the back.
Can you comment a little bit on how U.S. Council might rescind the
I'm sorry, somebody coughed just as you said it. How the USGBC would rescind?
Would rescind the LEED certification after the fact.
The only way I've heard of that being done is if there's an appeal and it turns out that, the question was, can the USGBC or would they rescind a LEED certification? There have been a few appeals where somebody's pointed out that in fact some of the claims made and submitted were erroneous. That hasn't happened very often. There is discussion about making a LEED NC plaque sort of just one part of the pie, and you don't get the whole plaque unless you also go for LEED EB. And so to that extent, you can always claim that you got the plaque when you designed it and constructed, but if you don't show that you're operating it in a green way that comports with EBOM, which will change over time, you might not get that wedge. That's as close as I can come to your comment. There was another, yes.
I'm interested in, I think it was the Solara project that showed the resident consumption spectrum from 3,000 kilowatt hours on one side to minus 1,000, I think, if I recall, on the other.
Yeah.
I assume, but I want to be clear, that that was after a certain renewable budget had been declared, or did each of these units have somehow connected to their own renewable energy systems?
Actually.
And was that an annual or?
Those were annual usage, and this particular project was set up so that every unit had its own PV system and an electric meter. So we had absolute ability to measure the comparative electric usage of each system. That's not a particularly good way or efficient way to design a system, but this was a research project where we wanted to be able to do that level of comparison. But the scale doesn't work out very well. You know, you've got a lot of inverters and meters and stuff that isn't very efficient. But on the other hand, you would think that if people were paying their own electric bill, they'd be more interested. And yet you saw the variation in usage, and those people were paying their electric bills. And it was a low-income housing project where costs were ostensibly important to the occupants, but still huge variations.
I'd like to talk to you more about that because it's very relevant to a project we're getting into. So can I?
Sure. I'm here all afternoon.
One more? Yeah.
Net zero energy buildings. Can you hear me now?
I can hear you, but I don't think it's on.
The current technologies for net zero energy buildings can only sustain a certain density of population in human activity. So how do you see or envision the future of net zero integrating into our urban developments and our urban fabric? Because the way they're designed now are not advantageous to urban settings.
I think, so the question is, how do you deal with higher density buildings and so forth? For me, the place to start thinking about that is at a campus context. I mean, you can imagine setting a goal of having Dartmouth be a net zero campus. Now, I don't know what you do with this large fuel oil burning electric plant over here, but let's think about that for a minute. I mean, you have buildings like labs that are very high intensity. You have a lot of other buildings that are relatively low intensity. And if you mix and match and look at it, draw the boundary around the whole campus, and maybe even include an off-site part of the boundary where, like on the golf course or something, where there's a PV farm. There are ways of thinking about it. Certainly, it's much more challenging in an urban environment where you have high rises with relatively little footprint and very high energy intensities. There you need to be thinking a lot more about district cooling and heating and combined heat and power, cogeneration systems, things like that, where hopefully you're using biogas or other renewable sources to fire those things. But you're not going to do it all just with a windmill on the roof or PV on the roof. It's got to be much more sophisticated and larger scale systems, but there are still ways of doing it. I mean, the UCLA campus in Los Angeles is 80%, I think is the number, fueled using methane that comes from a local landfill. I mean, it's an enormous 50 megawatt cogeneration system, a big plant. So, I mean, there are ways of doing it renewably. Are we done, Jack?
I think we have time for one more. Yeah, 1 minute. 1 minute.
Another one? Over there? Sorry, the minute's up.
I was wondering if you could maybe quickly comment about how do you find good predictive models of user behavior?
So the question was good predictive models of user behavior. I mean, we can't even do good predictive models of energy usage, assuming idealized humans, right? One of the areas that we're actually working in and lead is to add a social equity component, which is intended to look at human factors, both, I mean, first of all, the impacts of buildings on people at both the building scale and community scale. But the other side of it is how do people interact with the building? And I mean, most of the systems are very unfriendly and there's not good communication, you know, and yet in these days, I mean, you could imagine the building talking to the occupants saying, hey, close the window because it's hot and humid outside, or, you know, I mean, there could be a lot more meaningful ways of buildings interacting. I'm not a social scientist, and I don't really have a good answer to your question, but it's certainly an area that we need to go into. But I think one thing is that you need to educate the people in the buildings so they understand it. I mean, I've walked into dozens of daylit buildings that I've designed and noticed that there's masking tape over the photocells. And you say, well, what's going on here? And they say, oh yeah, you know, the lights went up and the lights went down, and we found that when we put the tape over it, they were just nice and steady all the time. Yeah, I think they missed the point, you know? But the point is nobody ever told them, you know? And so we need to educate people. And I think as we do educate people, that they will get into it. I mean, people buy into that Healthy Planet, the cartoon, you know? I mean, people want that, but they don't know how to contribute to it. So I hope that motivates people. Thanks.
Thank you.